Let's have a brief review on the properties of acids and bases. Robert Boyle summarized the properties of acids and bases as follows. Acids have a sour taste. Acids are corrosive. Acids change the color of certain vegetables' dyes, such as litmus from blue to red. Acids lose their oddity when they are combined with alkalis.
The name acid comes from the Latin acidus, which means sour, and refers to as the sharp odor and sour taste of many acids. For example, vinegar tastes sour because it is dilute, solution of acidic acid in water. Lemon juice tastes sour because it contains citric acid. Milk turns sour when it spoils because lactic acid is formed. And the unpleasant, sour odor of rotten meat or butter can be attributed to compounds such as butyric acid that form when fat spoils.
The properties of base or alkalis are the following. Number 1 is alkalis feel slippery. Number 2 is alkalis change litmus from red to blue. Number 3, alkalis become less alkaline when combined with acid.
Well-defined alkalis as substances that consume, neutralize acids. Acids lose their characteristic sour taste and ability to dissolve metals when they are mixed in alkalis. Alkalis even reverse the changes in color that occurs when litmus comes in control with an acid. Eventually, alkalis became known as bases because they serve as the base for making certain salts.
Arrhenius suggested that acids are neutral compounds that ionize when they dissolve in water, give hydrogen ions, and a corresponding negative ion. According to this theory, hydrogen chloride is an acid because it ionizes when it dissolves in water to give hydrogen and chloride ions. Arrhenius argued that bases are neutral compounds that either dissociated or ionize in water to give hydroxide ions and a positive ion. Sodium hydroxide is an Arrhenius base because it dissociates in water to give the hydroxide and sodium ions.
An Arrhenius acid is therefore any substance that ionizes when it dissolves in water to give the hydrogen ion, and Arrhenius base is any substance that gives the hydroxide ion when it dissolves in water.
Bronsted-Lowry acid is any species that can donate a proton. This is hydrogen ion to another molecule, and the Bronsted-Lowry base is any species that can accept a proton from another molecule. In this slide, Bronsted-Lowry acid donates a hydrogen ion to Bronsted-Lowry base. To determine whether a substance is an acid or a base, count the hydrogen ions on each substance before and after the reaction. If the number of hydrogen has decreased, that substance is the acid. If the number of hydrogen has increased, that substance is a base.
Since a hydrogen atom has only one proton and one electron, when hydrogen loses its only negatively charged electron, becoming hydrogen ion, there is only the proton left.
Acids and bases can be classified as strong or weak. So what is meant by a strong acid? It is important to know that the number of hydrogen ions or protons that can be given off by a particular acid. This determines an acid's strength. A strong acid is any acid that ionizes completely in solutions. The strong acids are hydrochloric acid, nitric acid, sulfuric acid, hydrobromic acid, hydroodic acid, perchloric acid, and chloric acid.
A weak acid is an acid that doesn't produce hydrogen ions when in aqueous solution. Weak acids relatively have low pH values and are used to neutralize strong bases.
These are the examples of weak acids. These include the acetic acid or vinegar, lactic and citric acid, and phosphoric acid.
A weak acid is partially dissociates in a solution, while the strong base is one that fully dissociates and gives ions in solution. Example of weak base is ammonia. while strong bases are sodium hydroxide and potassium hydroxide. My next topic is about auto-ionization. The self-ionization of water is an ionization reaction in pure water or aqueous solutions, in which our water or H2O deprotonates or loses the molecules of one of its hydrogen atoms to become hydroxide ion. The auto-ionization of liquid water produces hydroxide ion and H3O plus ions. The equilibrium constant for this reaction is called the ion product constant of liquid water. Even pure water has an amphipathic nature. This means that a small amount of ion will form into a pure water.
Some molecules of water will act as an acid, each donating a proton to a corresponding hydrogen molecules that acts as a base. Thus, the proton donating molecule becomes an hydroxide ion, while the proton accepting molecule becomes an hydronium ion.
The pOH scale is similar to the pH scale in that a pOH scale of 7 is indicative of neutral solution. A basic solution has a pOH less than 7, while an acidic solution has a pOH greater than 7. The pOH is convenient to use when finding the hydroxide ion concentration from a solution with a known pH. pH is usually between 0 and 14. If pH is less than 7, the solution is acidic. If pH is equal to 7, then the solution is neutral. If pH is more than 7, the solution is basic.
The slide shows the pH of several solutions or materials. Example, the pH of pure water is 7, which is neutral. The pH of detergent is 10, which is basic. And the pH of lemon juice is 2, which is acidic.
So what is Bronsted-Lowry acid and base versus Lewis? A Bronsted-Lowry acid is a proton donor, while a Lewis base is an electron donor.
As with the hydrogen ion concentration, the concentration of the hydroxide ion can be expressed logarithmically by the pOH. The pOH of a solution is the negative logarithm of the hydroxide ion in concentration. Like hydrogen ion, when a proton accepts electrons donated from a Lewis base like hydroxide ion, it exceeds its valency and must break its bond with a given atom on a Bronsted-Lowry acid, like the nitrogen on NH4. If a bond between a Bronsted-Lowry and a proton breaks, the Bronsted-Lowry acid donates a proton. Thus, a Lewis base can donate electrons to acquire a proton, while the Bronsted-Lowry acid had donated that proton.